ways to look at it. And then we integrate again, right? Integrate one more time, what happens? How about this? R of t is the integral of dr dt. dt as it happens. And so that's the integral of, I'll go back to my this notation since you guys are probably most comfortable with this notation at the moment. But I'd like to point something else out in just a second here. So integrate each one of these, what does this give us? V naught xt, V naught yt, V naught zt, right? Minus 1/2 gt squared plus some other constant, let's call it 2, right? Again, if r of 0 is given as r sub naught, that would be the C2 vector, right? So therefore, r of t, so we have x naught plus v naught xt, y naught plus v naught yt, z naught plus v naught zt minus 1/2 gt squared. There's the position at time t, assuming, of course, that the initial position is x naught, y naught, z naught. I mean, y naught. Oh, I'm sorry, that was horrible. But I mean, so yeah, we've got these sort of scalar equation versions here, you know. So starting with A, let me just sort of champion the vector notation for just a second. You can compare this, right, and this to the corresponding vector equations. The vector notation, what's the acceleration? It's minus g z hat. What's the velocity? Velocity at time t? Well, it's the initial velocity minus gt z hat. What's the initial position? What's the position? Well, the position is the initial position plus t times v naught, right, minus 1/2 gt squared z hat. Once you gain confidence with the calculus of vectors, what I've written in purple is by far a more efficient way of seeing these calculations, right? You don't really gain anything from breaking it up into x, y, z with commas. But anyway. But there you go. Of course, you might recognize these. These are what? The constant acceleration formulas, right? There's no acceleration in the x and the y, and just the z has the acceleration piece. All right. So what do we know? What are properties? You know, what are properties of the calculus of curves? So those we'll talk about next time. But there's all kinds of neat formulas that relate derivatives to dot products and cross products and all that stuff. So, but tomorrow. Thanks, guys.